Although we use them interchangeably, sometimes we call these gauge R&R studies, we try to refer to them as the total measurement system. The reason being that it's not just the piece of equipment, it's the person, it's the procedure, it's the environment, a point of reference that the gauge may go back to, and those things in total represent the measurement system, which then produces a data point or a measurement for our project. So we look at it as the system as a whole and all of the different sources of error that could result in the measurement being inaccurate. In this section, we're going to look at two types of measurement system assessments. One for variable measures. So I've got a continuous scale. We've got things like pull strength and weight and cycle time. So I can take the measure and divide it into smaller and smaller increments. And then on the other side, where I have just its go, no go, pass or fail, all the way up to some type of ordinal scale, would be for an attribute study. So we are going to start on the variable side, things like cycle time, pressure, weight, other things that I can measure where I can take the measurement, divide it by 2, and it still makes some logical sense. Here are the simple mathematical representations of the error that could be introduced by the measurement system itself. So eventually when we make measures, we collect data, we'll be able to compute a mean, right, the average of the data, and a standard deviation or a variance. Now those are composed of, let's look at the mean first, what we calculate as the true process mean. We're going to add up all the data, divide it by n. But if there's any bias in the measurement system, right, that's included with the measure. So what I have observed may be offset by some offset in the measurement system. Likewise, variability is also additive. So I'm going to get a variability due to the process itself, plus any variability introduced by the measurement system. So there's always an inflation of the overall process standard deviation that's due to the measurement system. So we'd like for that to be as small as possible. So we know that this relationship exists. We're going to go back and measure how big is this term. So looking at error in sort of tree diagram format instead of with equation, we're going to collect data, right? So we call those our observations, our measurements, and within those are contained the true process variability, which is really what we want to measure, and then we have, right, good old error that comes in that impacts our observation. And there's two sources that we'll talk about in this course, one being the measurement system, which we're going to talk about now, and then when we get into the analyze phase, right, the fact that we're sampling from the process also introduces some error. So we're always on guard for error. We're always on guard for inflating the standard deviation or the variance of our data. So we're going to start over here on this side. What kind of errors are introduced by the measurement system, and can we quantify them and determine that they're acceptable for what we're trying to do in our improvement effort. So now we take the measurement system error leg and we break it into two branches here. Accuracy, so all of the things under accuracy being things that might impact where the mean lies, any kind of bias we're going to introduce. And then over here on the precision leg, is where we get into the R and the R, the repeatability and reproducibility, along with the discrimination of the measurement system itself. So let's start over here on the accuracy leg, or any bias we might introduce to the mean of the process output.